Okay, so I'm going to also leave the chat open, and I'll try to be a little better than I was last week. I did not see some of those chats coming in, even though I had it open. So I will try to be better at that. If you guys see a chat that I'm not seeing, you know, yell at me. Um, okay, so this section 3.1 is talking about measures of center. So you guys have probably seen a lot of this stuff in the past. We have mean, median, and mode. So the mean is just the average of the numbers. The median is our middle number, and then mode is the most frequent. We can have multimodal if we have multiple sevens and multiple 12s or whatever. You can have two modes. And then mid-range, which is the minimum plus the maximum over two. That's not used very often. In fact, I think I've only used it once in whatever 25 years of doing statistics. So it's not used very often, but occasionally it is used. So let's look at finding these. This is a data set that I have, and it's a couple of things I want to point out. So we have our data set. Now, notice that I have this n equals 7 here. That little n is always going to represent the sample size, and all that means is just the number of values that we have. So if we count the number of values we have 7. That's our sample size, our n. Okay, and we'll use that throughout the course. The mean we're going to denote by this extra little bar on top of it, which I'll call x bar for obvious reasons. And what we do there is we sum up all the x values. That's what this capital sigma x means. That just means add up all the values. So the 5, 6, 6, 7, 10, 13, 15, divide by 7, okay, which is the number of items we have. Okay. Now the median is found a little different. What we do there is we take our sample size plus 1 over 2, okay? And in this case, our sample size is 7, so we have the 7 plus 1 over 2, 8 over 2, or 4. And that tells us what position to take. So in this case, that's our circle number. That's the middle number. Okay, make sure the data is sorted. MyStatLab always has it sorted, so that helps you out. But we're just trying to find the middle number. Now, if our sample size was even, say instead of 7, it was 6, then we'd have 6 plus 1 over 2, which is 7 over 2, and our result would be 3.5. So anytime we have something that doesn't come out a whole number, like in this case 3.5, it's either going to be a whole number or something and a half. If we only have 6 data elements, say we didn't have this 15, there's no true center because the center should fall halfway between 6 and 7, all right? Because there's 3 on either side. And that's what this 3.5 is telling you. Say, okay, if we have an even number, we're going to split the difference between, in this case, the third and the fourth value. So we take the 6 and the 7, and we'd average those. So anytime there's not a true middle, we just force the middle halfway between the two on either side. We'll be using StatCrunch for most of this, so that'll all be worked out. Just want to kind of give you an idea of what's going on. The mode is the most frequent number, so we have multiple 6s. Everything else occurs just once, so our mode is 6, the most frequent number. And then finally, our mid-range, we take our min and max. Okay, so we have the 5 and 15 for our min and max. We add those together and divide by 2. Okay. All right. All right, so let's look at measures of variation. So we measure variation. We have a range. Okay, so we have our we had our first quiz due last night. So let's think about our range of the quizzes. Okay, so I'm teaching I think 6 sections of this course. So I have them all combined. So I would imagine out of someone out of the 6 sections, and maybe in this section, I would imagine the max score is probably 100 or very, very close to 100. And the minimum score was probably a 0 because I'm sure there's somebody that hasn't taken it yet. So the range of those quizzes last night were, probably 100 or very close to it. What we're going to focus on here is the standard deviation variance, more specifically the standard deviation, which we're going to call S. And what that is a measure describing how compact or how spread out the data is. Okay. The variance is related to the standard deviation. That's just the square of the standard deviation. So if the standard deviation is S, the variance is S squared. About the only thing we do with the variance is take the square root of it to get the standard deviation. What we use most cases is the standard deviation. So I have an example of how we can find this. Okay, so I have this data set, 6, 7, 10, 13, 14, and we want to find the range and standard deviation for that. So the ranges are real easy. It's just the max minus the min. So we have the 14 minus 7. I'm sorry, 14 minus 6, which gives us 8. So nothing too terribly difficult there. Now the standard deviation. This can be a little bit tough to do all this. Right. I want to show you how standard deviation works, how it's calculated. When you guys are actually doing this, I would highly recommend using StatCrunch, and I'll show you that later in the course because this definitely can be tedious. All right? So let's look at this formula and see what we have here. We're going to work inside out, so we're going to start with this x minus x bar. Our x bar is just our sample mean. Okay. So that's what we found earlier. I found that over here in the corner. Okay. So then we can add up those 5 values, the 6, 7, 10, 13, 14, and divide by 5. We have our mean of 10. So when we have this x minus x bar, what we're doing is we're taking each individual x value, which is the 6, 7, 10, 13, 14, and subtracting the mean. That's what I've done in this column here. Okay. So so we have the 6 minus 10, which is the first value, which is -4, 7 minus 10, -3 the second one, and then so forth. So we take each one of the values, subtract the mean. That takes care of the inside part. And as we move further out, we have to square all those values. That's what I've done in this last column. So we have the -4, we need to square that to get to 16, -3 squares 9, so forth. Now that we have all those squared values, we have this capital sigma. What that means is add them all up. So add up the following. So we're adding up those squared values. In other words, we're adding up these values, and that's going to give us the 50. Okay. N is, remember, our sample size. So we have, sample size is 5 minus 1. The sample size is 5, and then we subtract 1. So we have 50 over 4, or square root of 12 and a half, which comes out 3.5. Now, I've made this problem specifically to have the numbers work out easy. I had picked up real easy numbers for our data set. I made sure that the mean was nice and easy so that I could do all these numbers in my head. If you're doing this in real world application, you're probably going to have a data set that's much larger than that, maybe 20, 30, 40, could be 500 data elements. Trying to do that by hand with that many data elements is just, that's not going to work. You're going to make a mistake somewhere along the way, and it's going to get pretty out of control quickly. So we'll do that by StatCrunch. There's a second formula here for standard deviation. I just want to point out one thing: the difference between the sum of x squared written like this and the sum of x quantity squared written like that. So here, this first one, what we do there is we square all the values first and then add them up, where here we add up all the x values and then square it. So here we square first and then add, here we add, then square. So I've done both those. So here's all our x values. If we add all those up, we get 50. And we take that 50 and we square it. So we add them first, then square them. And then this first one, we have all the squared values, so we square them all first and then add them up to get the 550. Okay, either formula is about the same amount of work. Again, I would recommend StatCrunch on that. Okay. All right, so here's some symbols that we'll be using throughout the course. I just kind of want to, look at these so that we, see them for the first time. And then we will, I'm sorry, trying to do two things at once. So here we have X bar, which we've talked about. That's our sample mean. We also have a population mean. So quite often we'll say mean interchangeably, but we have to look at the symbol. Anytime they have X bar, that's our sample mean. Anytime they use the Greek letter mu, that means the population mean. And same idea for the standard deviation. We have the sample standard deviation, which we're calling S. And then we have our population standard deviation, which is that Greek letter sigma, lowercase sigma with a little O with a hat on it. And then, of course, our sample size n. Okay, so that's not pertinent now, but it's something definitely to know and keep in mind as we move on in the course. Okay. All right. All right, now here, this is an important concept here. So once we have a mean and a standard deviation, we can start saying some things that are pretty important, especially this course. So it says, what I have written there is most values fall within 2 standard deviations of the mean. And below is an important concept that will be utilized in the course from here on out. Okay, so we have our population mean here. Okay, right down the center. And if we go out 2 standard deviations, or add 2 standard deviations to the mean and subtract 2 standard deviations to the mean, that's going to give us this range of this yellow region. Anything in that range is likely to occur. Those are, when they say not significant, those are common values. Okay? Anything beyond 2 standard deviations above the mean and below the mean, either going to be significantly low or high, depending on which direction they are. Right? Now I'm going to refer back to this a bunch of times, and I'm going to talk about inside 2 standard deviations or outside 2 standard deviations over and over and over again. So this is something I'm going to come back to, throughout the course. I'm going to probably say it enough times today that you'll get tired of me saying it. But I will continue to say it for, a while. So, that is definitely an important concept, and, one that we'll be building on as we go. Okay. So right now we just have to know that trying to find, I closed out something here and I'm trying to figure out how to bring it back, but I can't seem to figure out how to do that, of course. All right, well, oh well. All right. So again, we're going to use this. Now, as the course goes on, we're going to get more specific about this, but right now we just have to know inside 2 standard deviations is likely to occur, outside 2 standard deviations is unlikely to occur. Now, this next rule is going to be a little bit more specific about that. This is a kind of a special situation. So here, this empirical rule says when you have a normally distributed data set with a mean and standard deviation known, the following percentage of data falls within 1, 2, and 3 standard deviations of the mean. All right, so let's figure out what the heck we're talking about here. So if we have some mean and some standard deviation, say our mean is 10 and our standard deviation, I don't know, maybe is 2, okay? So our standard deviation, that's supposed to be an S, is 2, all right? So if we have that, that tells us our mean is right down the center at 10. If we add and subtract 1 standard deviation, so if we subtract 1 standard deviation, we'll go down to 8. We add 1 standard deviation, we'll go up to 12. What this empirical rule tells us is that 68% of the data fall between 8 and 12, or 1 standard deviation below to 1 above. If we got 2 in either direction, so if we go down 2 standard deviations to 6 and up to 14, that's where roughly 95% of the data fall. Okay. So, and then if we go out 3, it goes up to 99.7. So let's go back to our little double arrows here and see how this plays into it. So what they're saying, if we apply this to the empirical rule, what they're saying is 95% of the data elements fall between 2 standard deviations below and 2 standard deviations above the mean. Okay, so that's where 95% fall. So when we look at the significantly high and significantly low, they total 5%, 2.5% in each direction. Right? And that's what we're using as our cutoff. Inside, 95% is going to fall inside 2 standard deviations. The other 5%, 2.5 in either direction, are going to be significantly low and significantly high. So that's where that's coming from, with the plus or minus 2 standard deviations. All right, so let's use this empirical rule. So what we need to know about the empirical rule is we basically have these 3 numbers, and that's within 1, 2, and 3 standard deviations. So once we know it's 1 standard deviation, we know it has to be 68. If we know it's 2 standard deviations, 95, 3 standard deviations, 99.7. So there's our answers. We just have to figure out which case we have, 1, 2, or 3. All right. So in this example, it says male heights are approximately normally distributed with a mean of 70 inches and a standard deviation of 3 inches. Okay. So that we have that it's normally distributed, a mean, and a standard deviation. So we can use the empirical rule. It says, what is the approximate percentage of males between 67 and 73 inches? So we just have to figure out if this is 1, 2, or 3 standard deviations away. So if our mean is 70 and we're going down to 67 and our standard deviation is 3, that means we'd have 1 standard deviation below. So 70 minus 3 gets us to 67. The 70 plus 3 gives us the 73. So it's 1 standard deviation below to 1 standard deviation above. We have 1 standard deviation below and above. That would be our 68%. Okay. Right. Same thing we would do in part B. Here we have between 64 and 76. So we just have to, again, figure out how we get there. So if we take 70, subtract 3 once, we're at 67. If we subtract 3 a second time, then we're at 64. So that's 2 below. Same thing for 76. 70 plus 3 plus 3, that's going to be 2 above. So within 2 standard deviations, we get to 95%. So we'll have to, those are always the answers, 68, 95, or 99.7. We just have to figure out if we're, 1, 2, or 3 standard deviations away from the mean. All right, now we have the Chebyshev's theorem. This is very similar, but the difference here is it's not requiring a normal distribution. So here, the Chebyshev's theorem is a theorem which is valid for any distribution of the data. So it does not have to be normal. It can be any crazy distribution, and this will hold. So we can have a distribution, that goes like this or whatever. Whatever the distribution is, this will hold up. Okay, so it has less requirements. So here it says for any number k greater than 1, at least 1 minus 1 over k squared, the data will fall within k standard deviations of the mean. Okay, so let's put that in English here. All right, so let's give it an example. It says, suppose the data set has a mean of 50 and a standard deviation of 10. Again, it does not have to be normally distributed. Use the Chebyshev's theorem. Using Chebyshev's theorem, what percentage of the data will fall between 30 and 70? So we have to do the same thing as we did before. We have to figure out, okay, is that 1, 2, 3, 4 standard deviations away? So if our mean is 50 and our standard deviation is 10, to get to 30, we would have to subtract 2 standard deviations. To get to 70, we'd have to add 2 standard deviations. So that's where the 2 comes from. So now that we know that our k is 2, we plug k in there. So we have 1 minus 1 over 2 squared, which turns out to be 1 over 1 minus 1/4, or 3/4. Okay, so at least 3/4 of the data falls within 2 standard deviations. Now, at least 3/4 or 75%, whichever way they ask for it. And that's how we do it. So we just plug in however many standard deviations we're going in either direction. We just have to plug that in for k and then calculate what that comes out to be. That's going to be at least that much. The Chebyshev's theorem is not used near as much as the empirical rule. I have a few problems in the homework there, but I think that's about it. I'm not going to test heavily on that or anything. I need to have it in the course to make sure I have everything, but it's not used very much. All right, let me stop there for a second to see if anybody has any questions. Then I'll pick up. Is everybody good on what we've done so far? Any questions? Okay, looks like you guys are good. All right, so let's pick up there. Okay. Oops. Let me put the chat back up. All right. Now the next block here is measures of relative standing in box plots. So so this first thing is a z-score. So it says a measure of how many standard deviations above or below the mean of a data point is. So we have this formula. Let's see what that represents. Okay, so I think an example of that would probably be the best idea. So here it says male heights are approximately normally distributed with a mean of 70 inches and a standard deviation of 3 inches. Okay, so we've seen that before. And then it says that Shaquille O'Neal has a height of 85 inches. What would his z-score be? Right? So what we're doing is we're plugging that into our formula here. We have our score of 85 inches. We know our mean is 70, and we know our standard deviation is 3. So we plug all those things in. So we have the 85 minus the 70 over 3, which is 15 over 3, or 5. So what that tells us is Shaquille O'Neal's height is 5 standard deviations above the mean. Okay. So if we go back up to our little normal distribution, we have most of the people, 99.7 of them, falling within 3 standard deviations, and Shaquille O'Neal is way over here. Okay, he's off the chart by quite a ways. Now, does that make sense? Absolutely. I mean, he's like super duper tall. So yes, we would expect him to be off the charts in the height category. Okay, he's exceptionally tall. Now, I happen to 70 inches is 5 foot 10 inches. That's happens to be exactly the height that I am. So if we plugged in my height, we put 70 minus 70 over 3. 70 minus 70 is 0. 0 over 3. I would have a z-score of 0, meaning my height is right down the center. Okay, I'm of average height, not above or below at all. Okay. Now, if somebody's below 5'10", they would have a negative z-score. So their z-score, depending on how much shorter they are, it could be anything, but it would be negative. So all the z-score is telling us is how many standard deviations above or below the mean you are. Okay. All right. Let's see. Now we have percentiles. So we can, if we have a set of data, we can break it up into different percentiles. And what that means is, say we have the 40th percentile. What that means is that's the point where 40% of the data is below that value and 60% of the data is that value or above. Okay, it splits the data into 2 groups. Okay? So let's figure out how to do something like that. So we have this our fish length data, and notice that when I first wrote all these down, these were out of order. Okay, the first thing you have to do is put the data in order. So I reorder the data from smallest to largest here. Okay, StatCrunch does that for you, but if you ever have to do this on your own, you definitely need to have them in order to do this. Otherwise, you're going to make a mess of it. Okay? And what we're trying to do in this case is find the 75th percentile. Okay. And the first thing we need to do is we need to find what we call an L, or the L value. And that's the percentile in question, in this case, 75th, over 100 times N. Now, N is just the number of fish we have. In this case, we had 30. I'm going to trust my calculation from before. Okay, so we had 30 fish. The 75 is the percentile we're trying to find. So if we take 75 over 100 times 30, we get 22 and a half. Now, what that is the position number that we need to take. And we have 2 cases. We have L if it's a whole number, or if L is not a whole number. Right? We have the second case. If we have L as a whole number, we would average that value in the next one. We don't have that case. We have not a whole number, so we round that up to the next whole number. So even if it was 22.1, we round it up to the next number. So we always round up, which is the 23rd position. Okay? So we count over, if we count the data, we got 1, 2, 3, 4, going all the way over, and this is our 23rd value, 29.5 inches. So what that means is, when we were catching these fish, 75% of them were less than 29.5 inches, and 25% were 29.5 inches and above. Okay, so we're just grouping the fish. Now we can do that in the opposite direction as well. So if we wanted to have we catch a certain size fish and we want to know what percentile that is, we can do it the other way. So in this case, what we just did is we were given the percentile and we had to find the value of the fish. But if we're given the value of the fish, we can also find the percentile. So in other words, going backwards, right? So let's see how we do that. So say we want to find the percentile for a 35-inch fish. Okay? So we have the number of values less than 35, so the number of fish less than that over the total number of values or the total number of fish, and then we change that into percentage. Okay? So let's kind of figure out what we're doing here. So, say, me and my buddies are out fishing. I mean, one of the main things about fishing that we like is talking trash. And, if you catch a big fish, then you can talk trash and the other guys have to listen to you until they do, they catch one bigger. So if we catch a 35-inch fish, we want to know what percentile that is just to figure out, okay, what's the chances of our buddies, catching one bigger? If it's a high enough percentile, then we start talking trash. And if it's not high enough, then, we might want to stay quiet for a little while until we catch a bigger fish. So here's the 35-inch fish. What we do is we count all the number of fish below that. Okay, so we add all, count how many of them are below, which turns out to be 27. And there's a total of 30. Okay, so when we see this, the total number of fish less than 35 is 27 of them are under 35 inches out of the total of 30. So 27 over 30 is 0.9. 0.9 times 100% will give us a 90th percentile. So what that tells us is 90% of the fish are going to be less than 35 inches. So if I knew that, I think that's, certainly pretty likely that, I'm going to have the large fish of the day. So I'm going to start talking trash immediately until my friends just want to jump out of the boat. If that percentile was, the 50th percentile, I would probably stay quiet for a while. So you can see where percentiles are very, very important. I'm obviously joking here, but that's a case where that would be useful. Where percentiles were very useful for me was in grad school. Grad school works very weird. Basically, everybody in the class either gets an A or a B, and then if you do really poorly, you get a C. And a C is like an F in grad school. So they don't even give an F; it's just an A, B, or C. And if you don't maintain at least a 3-point average, then you can be on academic probation. So a C is really like an F. So every once in a while you run into a course in grad school that is really hard. The one that got me probably the worst was advanced calculus. I'm sure there's some useful information in advanced calculus, but I sure didn't pick it up. It was just a very hard course for me. It's hard for everybody, but it was particularly hard for me. So roll around the first test and I didn't do well. I don't remember what I got, but it was clearly in the F range. I don't know, 35% or something like that. And, so that's pretty scary if you get a test back that's at 35% and you're, supposed to be, you're trying to get a master's degree in this material and obviously you're not very good at it. So, again, grad school works like the top half of the class gets an A, the bottom half gets a B, and then if there's some straggler, they get a C. Well, what I was worried about is I just wanted to make sure that I was somewhere in that B range. I just didn't want everybody else to be having 70s and 80s, and I was, there at a 35. That means I was going to get a C in the course, and that wasn't good. So you just start asking around your buddies, just hoping that somebody is, did as bad as you. And I don't remember. I asked people, I don't remember what they did, but I have, one guy talked to me. He's like, "Yeah, you got a 62," and you're like, "Oh, yeah, 62 is pretty good." Like, I don't think I can do 62. And so he was got an A at 62, and but I'm like, I hope nobody else, not everybody else is way up there too. And you ask around long enough, and then I found a couple guys who were closer to me, and I'm like, okay, I think I'm still in the B range. So that's a case where it's not so much how you did on the test, but how you did relative to everybody else. And I was high enough that I wasn't worried about the C, but I was certainly not worried about an A either. So, anyways, that happens sometimes. Okay. Now we have five number summary. So this five number summary, we have the minimum, Q1, Q2, Q3, and maximum. So before we get too involved, let's figure out what Q1 means. Right? Q1 just means the first quartile are P25. So it's just a fancy name for P25. First quarter, 25% below, 75 above. Q2 is 50-50. Notice that there's three names for Q2. You have Q2, which is also P50, which is also the median. It's the middle number, half below, half above. Then, of course, Q3 is our 75th percentile, and then the max is the max. All right, so what we're going to do is we're going to take our fish lengths again, and then find these five number summaries. So the first one is the minimum. That's pretty easy. That's just the smallest fish. Okay, so we have the 13.25-inch fish. Now Q1. Q1 is the same thing as P25. So we have to calculate that L value like we did earlier. So it's the 25th percentile. So 25 over 100 times the number of fish, which is 30, which gives us the position number of 7.5. So that's not a whole number. So just like we did before, we have to round that up to the 8th position. So if we count over 8 fish, 8th fish is 16.25. Okay. And then Q2 is the same thing. That's P50. So we have 50 over 100 times 30. Okay, so now we've just changed it from 25th percentile to 50th percentile. So 50 over 100 times 30 gives us 15. Now here's the first case where we had a whole number. So anytime we have a whole number, what we do is we average that position, 15, and the next one, 16. So that's why I have both of these underlined. We average the 20 and 22, and that's where the 21 comes from. Okay, so was no true middle there, so we had to force it halfway between those two. And then Q3, we have the 75th percentile. We get 22.5. We'll have, since that's not a whole number, we got to round that up to our 23rd position, which is 29.5. And then finally our max at 40. Okay. All right, so that's our five number summary. Now let's see what this box plot is and how this comes into play. These vertical lines are our five number summaries. There's our minimum, 13.25. There's our Q1, Q2, Q3, and Q4, or max, I should say. Sorry. Okay. Go ahead, Caleb.
I was just wondering, since obviously how we're rounding up off of the positions, does it apply so for quarter two, when you for 20 and 22, if you had that to where you couldn't average that out to a whole number, like if you had 20 and 23, do you put the decimal there?
Correct.
Okay.
Okay, so his question is a good one. So let me rephrase it, just so we all are on the same page. So he's saying, when we got a whole number here, we average the 15th and 16th position, the 20 and 22, and we got a whole number of 21. Now, his question is, say this was 20 and 23. That's obviously not, if we average those, that's not going to come out a whole number, and that's okay. Whatever those two average to is totally fine. It doesn't. The only time we have to worry about whole numbers and not a whole numbers is when we're dealing with the L, not when we're dealing with fish links. So we have obviously some values here that are not whole numbers, which is okay. Okay. So, good, Caleb?
Yes, thank you.
All right, no worries. All right. So we have this 5-number summary, and we start with this box plot. And the reason why it's called a box plot is because we box in the Q1, the Q3. That's where the box plot comes from. And sometimes it's called a box and whisker plot. Sometimes these little things that come out to the side, they call whiskers. Okay. All right. Now, let me ask you a question, and you can just answer it yourself quietly. If anybody wants to be brave enough to answer it for us all, that would be fine. Between what two values does most of the data fall? Okay, so if we look at this box plot, between what two data points or what two values does most of the data fall?
10 and
Okay.
40?
Say that again.
10 and 40?
10 and 40?
Yeah.
Okay. Well, that would
I
certainly.
mean, I say that because it's because it's marked as 1325, but it's in between 10 and 15.
Yeah. So I mean, if we go 10 to 40, that's going to cover all the data. But I'm thinking what my question is between what the min and Q1, Q2, Q3, between these 5 values, which ones between what 2 values would be the most data? I guess is my question. Anybody else want to take a guess? No takers? All right, I tried. All right, that's the challenge on our live online class. All right, so it's probably good that you guys didn't answer, because no matter what you answered, it would have been wrong. It was a trick question. So let's figure out what I was trying to get at. What answers I normally get? A lot of people will say, between the Q1 and Q3, right in this range, because you have that nice, pretty box. And then my next response is that's wrong. And they're like, well, let's look at these 2 boxes here, and from here to here looks like a bigger area than this one, so we'll guess that, and that's wrong. And then they say, okay, well, maybe it's from here to here, and that's wrong. So let's figure out what this is telling us. All right. So the 1325, that's our minimum. Okay, so there's our minimum there. This is Q1. All right, so the definition of Q1 is that 25% falls below it. Okay, so in this first range between the minimum and Q1, we have 25% of the data falling in this range. Okay, and then we have Q1 and Q2. Well, Q1 is 25 percentile, Q2 is the 50th percentile. So between the Q1 and Q2, again, 25% fall in that range.
Oh, it's
Okay,
all
you
the
guys
same.
probably-
No matter
They're all the
what.
same,
Yeah.
exactly. So this is 25 and this is 25. Okay. Now, so my question was, which one has the most data between it, and no matter what you said, you guys have been wrong. So that was entertainment for me. It didn't work out as well as I wanted, but it was an attempt at least. So let's see why I asked that question. Normally, when we look at a graph, we're looking at these areas that are larger. We say, okay, this box is, a big piece of the graph. Okay, but there's just as much in that big box as there is between this little area here and here. Then we have the largest area, or the largest distance between these two. Okay, now the box plot to me is very misleading, because your eyes are drawn to those bigger areas, or or the box, or whatever it may be, but they're all 25%. Now let's figure out why these two are so close together. That's our smallest region, and these two are so far apart, but they both still only have 25% of the fish. Okay, so let's figure that out. So the minimum of the Q1 is our smallest, and then Q3 to Q3 to the max is the largest, but they both have the same number of fish. Okay, so let's look at this. So what we're representing, here's our Q1 at 1325, and here's our, I'm sorry, there's our minimum at 1325, and here's our Q1 at 1625, right? Now notice that all these fish are very close together in size. I mean, the smallest one is 13.5 inches, and the largest one is 16.5 inches. It's only a difference of 3 inches. They're all pretty much the same size fish. Now let's look at from Q3 to the max. Those range from 29 inches to 40 inches. So those are 29.5 inches to 40 inches. So those range in size over 10 inches. So there's much more variation in these, whatever, 6 or 8 fish than these 6 or 8 fish in the beginning. Okay, and that's all that's saying. There's the same number of fish between 13 and 16.25 as there is between 29.5 and 40. There's the same number of fish in each group. One, all the fish are the same size in the first group, and the second one, the fish are all vary quite a bit. And that's all they're trying to tell us. The fish are more compact or more spread out, the size. So although the box plot is certainly useful in a lot of cases, it's not something you'd ever want to use in a presentation because it's not an intuitive graph at all. Okay, here's a graph from StackCrunch that makes it look prettier, but it's even more I guess obnoxious that everything is focused on this blue area. It's giant, it's big, it's blue, and then these other areas are just you got a little tiny line out here. Not you're not seeing that very much at all. So just be careful. It's to me it's misleading. Okay. All right. Now what I want to do now is I want to look at homework and show you guys how some of this stuff can be done on StackCrunch, and see if we can master that. As I'm pulling these up, this chapter 3 is fairly straightforward. I don't think any of you are going to have too much trouble with it. I mean, you're not going to get them all right the first time through or anything, but it's not so bad. Next week, we're going to look at chapter 4. That's a much longer and more difficult chapter. If you do have a calculator, that's when I would have that handy, so I can, I can help you, look for keys to help you do some of those problems. So chapter 3 is not too bad. Chapter 4 is definitely more time consuming and more difficult. So just make sure you're caught up. Don't try to do chapter 3 and 4 in the same week. You're going to want the full week for chapter 4. So I'm trying to scare you just enough to make sure you keep up and do chapter 3 and ready to roll for chapter 4 next week. All right. After chapter 4, it gets easier again. So chapter 4 is a sticking point for some students. So just kind of a little bit of warning. Probably not going to like me so much next week. So in this problem, they want us to find the mean, median, mode, and mid-range. Right. So we can certainly do that by hand, but StackCrunch can help us as well. We can click on a little box and open up that StackCrunch. And if we go under Stat, Summary Stats, and Columns, we can select that variable. And if we go down here to this gray box, all this stuff that's the dark gray is all default. Okay. So the n, the mean, the variance, the standard deviation, standard error, the median, the range, the min, the max, Q1, Q3, basically everything we've talked about today, all is default information. If we scroll down, a lot of this other stuff we didn't talk about, the only other thing that we did talk about was the mode. If you want to include the mode in that, you'll have to hold down either Control or Shift, one or the other, and then click on that. That'll add that to the list. If you don't hold down Shift or Control first, it will only find the mode. It'll eliminate all the other stuff. Okay. And if we hit Compute, here we have all our values. They ask for the mean. They ask for the median. Let me see if I can make this a little bit bigger. They asked for the mode, so they told us there's no mode. And the only other thing they ask us for is the mid-range. Unfortunately, StatCrunch doesn't calculate the mid-range, mostly because it's not used very much. But they do give you the min and the max. So to find the mid-range, we add those two together and divide by 2. So this one is, looks like we can probably do it in our head. The 2 plus 82 is 84. 84 divided by 2 is 42. So, our mid-range would be 42 in that case. Okay. All right. Let's see. I want to go to the next section. There's 4 problems in this section. All are identical to that. Find the mean, median, mode, and mid-range. So those are all very similar. Okay, and then we have 3.2. All right, let's see what we want to do there. We want to look at the first one. All right, so here we're trying to find the range, variance, and standard deviation. Okay, so the standard deviation range, that was those formulas we looked at right at the beginning of class that were pretty lengthy. This would be a pain in the butt to do by hand. Let's see how this will work with StatCrunch. So we open it up in StatCrunch, go to this exact same place, stat, summary stats, columns. I see the chat, let's see. Okay, the question is how do I add the mode on StatCrunch? Okay, so I'll go ahead and add the mode here. We don't need the mode in this problem, but we can add it. So first I'm going to select my variable. Okay, and everything here in the gray box is all default, the dark gray. So the sum and interquartile range and all these other things are not. If I want to add the mode, I have to hold down either Control or Shift, one or the other, and they give you a little note here. Notice, see that little yellow thing pops up. So I have to hold down either Control or Shift and then click on mode. Okay, and then that mode is added on there. If I just click on mode, it will add that one and eliminate everything else. Okay. All right, and then we hit compute. So in this case, they wanted the variance, the standard deviation, and the range. Okay, so we have those values all there. Okay. All right, let's see. The next one I want to look at is 4. Okay. So here it says a group of adult males has foot lengths of the mean of 26.82 centimeters and a standard deviation of 1.32 centimeters. Use a range rule of thumb for identifying significant values to identify a limit set of range values that are significantly low or significantly high. Is the adult male foot length of 23.8 centimeters significantly low or significantly high? Explain. Okay, so let me go back and just remember what we're doing here. All right, so this is talking about our little, arrow thing here. So what we're doing is we're trying to find these values that are separating the significantly low to significantly high. So they gave us a mean and a standard deviation. We take that mean and we add 2 standard deviations for the cutoff for the upper cutoff, and we subtract 2 standard deviations for that lower cutoff. Okay. Anything in between those is insignificant or not significant. Anything below the low one is low. Anything above the high one is high. Okay. So let's see. Okay. So in this case, so let me do that. All right. So here, they give us a mean of 26.82 and a standard deviation of 1.32, and they want us to find the significantly low. So that's 2 standard deviations below. So what I do is I take the 26.82 minus 132 twice. Okay, so I subtract that 1.32 from 26.82 twice, and that gives me the lower bound of 24.18. The significantly high is the other side. So I take the 26.82 plus 1.32 plus 1.32 again. So I add the standard deviation twice and get the upper bound of 29.46. So between 24.18 0.18 and 29.46. There's not, those aren't significant values. Anything below 24.18 is significantly low. Anything above 29.46 is significantly high. And that's what they're asking us the next question. We have a male foot length, or adult male foot length of 23.8 centimeters. Is that significantly low, high, or neither? Well, since the 23.8 is less than the 24.18, which is our lower bound, that would be significantly low. Okay. So they're going to ask this question a bunch of times. They're going to say, okay, find the lower bound and the upper bound. And then they're going to say, okay, this value, is it between, meaning not significant? Is it low? Is it high? Where does that fall? Okay, so in this case, it's significantly low because it's below the lower end. We'll look at number 6. Okay, so here, what are we doing here? Okay, so the body temperatures of the group, healthy adults have a bell-shaped distribution. Okay, so a bell-shaped and normally distributed is the same thing. So it's normally distributed or bell-shaped. They give us a mean and a standard deviation. And it says using the empirical rule, find each approximate percentage below. So the empirical rule is our 68, 95, or 99.7. We just have to figure out if it's 1 standard deviation away, 2, or 3. Okay, so we know we have basically a multiple choice, either 68, 95, or 99.7. We just have to figure out which case we have. So in this first problem, it says, what is the approximate percentage of healthy adults with body temperatures within 1 standard deviation of the mean? So they already tell us it's 1 standard deviation, or between 97.39 and 98.75. So as soon as they tell us 1 standard deviation, that's our 68. And then B, it says, what is the approximate percentage of healthy adults with body temperatures between 96.71 and 99.43? So we just have to figure out how we get from the mean using the standard deviation. How do we get from 98.07 to 96.71? Now, I don't know how to do this in my head, but basically what you're doing is you're taking the 98.07, subtracting the 0.68. From part A, I know that that's 97.39. And then if I subtract the 0.68 again, that's going to give me the 96.71. Okay. I don't have quite the skills to do that in my head, but I see that the answer is 95, so it has to be 2 standard deviations below. We do the same thing for the 99.43. Say, okay, how many times do we have to add that standard deviation to go from 98.07 to 99.43? And that is also 2. So if it's 1 standard deviation, it's 68. 2 is 95. 3 is 99.7. Okay, so we just have to figure out which one of those 3 we have. Okay. Everybody good on that one? And then we have our number 7, which is our Chebyshev's theorem. So here they again tell us we have a mean of 255.1 and a standard deviation of 65.3. And it says using Chebyshev's theorem, what is known about the percentage of women with palate counts that are within 2 standard deviations of the mean? So we're interested in what percentage fall within 2 standard deviations. So with that Chebyshev's theorem, we got to do 1 minus 1 over k squared. So in this case, our k is 2. So 1 over 2 squared is the same thing as 1 minus a quarter or 3/4. They want it in terms of percentage. So 3/4 is the same thing as 75%. The other thing they ask is our minimum possible and our maximum possible counts for 2 standard deviations. That's the same thing. That's going back to our inside 2, outside 2. Inside 2 is unlikely, outside 2 is, inside 2 is likely, outside 2 is unlikely. They want to know what are those cutoffs. So we have to take our mean and subtract standard deviation twice to get the lower bound. So 255 minus 65.3 twice is 24.5. and then 255.1 plus 65.3 twice is the upper bound of 85.7. Okay, so that gives us our cutoff of what's likely and unlikely to occur. Okay. All right, now let's look at 3.3. Okay, and I want to look at 7 and 9. Okay, 7 and 9 are going to look very similar. So I wanted to, show you both of these, just to make sure that you don't, get frustrated when you start doing these, because they're going to sound very similar, but you got to do them different ways. So here we use the accompanying radiation levels for 50 different cell phones and find the percentile corresponding to 1.10. All right, so they give us this table, and we're trying to find the percentile for this 1.10. All right, so to find the percentile, first of all, we got to figure out how many data elements we have. So this table, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So there's 10 columns and 5 rows. So there's a total of 50 data elements. So we have 50 data elements, and we got to figure out how many are below the 1.1, which is everything in these first 2 rows. Okay, so there's 2 rows of 10, so 20 of them are below 1.1, and then we just change that into percentage. So we multiply by 100%. So in this case, we have, that's supposed to be percentage, whatever. So 20 over 50 times 100, that turns out to be 40%. And that's where this 40 comes from. Okay. Now let's look at 9, which will look very similar, but we're doing it in the opposite direction. So in this case, it says use the accompanying radiation levels for 50 different cell phones. So we write back the same data set and find the 20th percentile. So the first time they told us, hey, they're giving us a cell phone radiation level and trying to find what percentile it is. And now they're giving us a percentile and we want to find the radiation level. Okay, so we got to go the opposite direction. This is where we use that L value. So our L, we take the percentile in question. In this case, we're trying to find the 20th percentile. We put that over 100, so it's always going to be over 100. Okay, and we multiply by the number of data elements we have, which in this case, they told us we had 50 cell phone values. Okay, so if we have 20 over 100 times 50, that turns out to be 10. Okay, so 10, that is a whole number, so we have to average the 10th and 11th value. So if we find our 10th value, which is 0.82, and our 11th value 0.87, if we average those two out, we're going to get 0.85. Okay. They just asked for 2 decimal places here. If you average 82 and 87, it's actually 0.845, but we had to round that because they asked for 2 decimal places, which gets it to 85. So I don't think either one of those are particularly hard, but make sure you're using the right method for the right one. They sound very similar, look very similar. So if you start, getting confused, it's probably because you're using the wrong method. All right, and then question 12 here. All right, so 12, this is gave us this data set, and they're asking for the 5-number summary and then a box plot. So we'll open this up in StatCrunch, and we do the same thing as we did before. We go summary stats and columns. We'll select that variable, and the default information is fine. We can hit compute. All right, so our 5-number summary, we have our minimum, we have our Q1, Okay, what about Q2? I don't see Q2. Any ideas what we can do for Q2?
You just subtract Q3 from Q1.
No. What's another what's another name for Q2?
50%
Q2 mean?
or P50.
P50 is another name. Okay, what's a third name for it?
Median.
Median, yes. So this is Q2 just hidden under a different name. So remember, Q2 is 50% below, 50% above, middle number, which is the median, and also P50. So P50, Q2, median all mean the same thing. So, if you're losing, you can't find Q2, it's just another name for it under median. And then we, of course, have Q3 and the max. Okay, so we have our 5-number summary there. They also want us to build a box plot that would actually be under graph and box plot. So if we select that variable, if we hit compute right off the bat, it's going to draw the box vertically, which is fine, but MyStatLab and the book do it horizontally. So when you're doing that, one of the options is to click the draw the box horizontally. Okay, it's pretty standard to do it either way. Just the book and MyStatLab use horizontally, so we can flip it that way. And once we have that, we can choose which one of our 4 box plots matches up. Okay. All right, so let me stop there. Okay, any questions on this material or anything in general? No takers? Okay. So let me just reiterate what I said earlier. The chapter 3, I don't think is too terribly bad. Chapter 4, some of you guys aren't going to like that so much. So make sure you're caught up next week because you'll want the extra time for chapter 4. If you have not done the chapter 1 and 2 assignments, I would recommend getting on those very quickly. I don't want anybody to fall behind. That is where trouble occurs in this class. So you keep up, ask questions where need be. That's almost everybody's successful. It's when you start falling behind is when things start getting difficult. So make sure you keep up. And of course, if you have any questions, ask at any time, and I'll gladly help you. Don't think I have anything else other than that. If you guys have any questions, stick around. If not, you can drop off and I will see you next week.
I wanted to ask how we can access the recordings.
Okay, so I post that on my website. Let me get that link. 1 second. Okay, so this is the link to my website there. I just put it in the chat. And I have all the chapter notes there, the ones I was just going through. At the very top of those notes will be the recorded lecture. Currently, the recorded lecture is from many semesters ago. I have all intentions of changing that to tonight's lecture, either later tonight or probably most likely tomorrow morning. It takes a while to upload and all that kind of stuff. So I'll update that, sometime probably tomorrow morning.
Okay, thank you for that. Can I also ask a question about one of the questions from the quiz?
Sure.
It was about the type of samplings. I'll just send the question in the chat. Give me 1 second, please. For this question,
yeah.
I was just wondering, how do we decide between random and stratified the question, the answer was
let me catch up here for a second. Okay, so let me pull up. Let's see here.
Yeah, I got this question wrong on the homework like 4 different times because I couldn't. He was stumping me too.
All right, so let's look at it and make sure we understand. There's somebody was asking about where the video lecture is. That's right at the top of that, and that is updated there. Okay, so let's see if we can find this. Okay, so we have these four different or several different methods. So the simple random sample, it says that. Oh, am I sharing this? I think I'm sharing this. Yeah.
You are.
So we have the simple random sample where we just randomly select people. We have systematic where we have some starting point and we take every fifth or every eighth in the line. And then convenience is just, whatever's readily available. And then we have stratified and cluster. These are the ones that are a little bit more harder to tell apart. So stratified data is grouped into some categories based on some characteristics. So we would have, by race or by political affiliation, some kind of different, group. Okay. And then we sample within each group. And then we know about each individual group and we can combine them. Now, cluster sampling, I read it quickly. I think that's the one it is. It says a method of sampling in which you divide the population into groups or clusters, such as city blocks or districts. So we're grouping areas, whether we're doing it by zip codes, we're doing it by neighborhoods, we're doing it by streets or whatever it may be. And then randomly select some of those clusters for your sample. This is important. All members of the selected clusters are sampled. Okay, so let's go back to your question there. So here it says, to determine customer opinion of their check-in service, American Airlines randomly selects 150 flights during a certain week and surveys all the passengers in the flight. So the key there is all. So when they're clustering by flights. So instead of randomly selecting 1,000 American Airlines passengers, they're all over in different flights going all over the world. What they did is they randomly selected 150 planes or 150 flights, and then they surveyed all passengers on those flights. And that all passengers in the flights, that's where it's a red flag for, hey, this is cluster. Does that help?
Yes, I see. Thank you.
All right.
So if you change just the word all, even though technically that is clustering, and if you just changed all to like every fifth passenger, then it's no longer clustering because all passengers are not being surveyed.
Right. So then it would be a kind of a combination because you're clustering and then you're doing it systematic, but they're not going to do both. But yeah, so anytime you say, okay, we're taking every 10th one, that's going to be your I'm drawing the systematic.
Okay, understood.
But the all just kind of helps you key in, oh, this must be cluster since they're taking all.
Right.
So that's just a kind of a red flag of when you're doing these.
Okay,
Right,
thank you
any
for
other
the
questions?
explanation.
So, okay, that helps.
Mm-hmm.
Okay. If you guys ever get stuck on these when you're doing the homework, on the bottom of every problem, there's that Ask My Instructor link, and you can send it to me, and I'll get back to you, very quickly. Just remember, I will respond to whatever email that you signed up with in my math lab. So whether that's your Gmail account or your FSCJ account, it'll go back to whatever that one is. But use me. I'm here.
Yeah, I sent you one about the stupid squirrel weights. That one kept getting about how many squirrels in a forest.
Right. And I got back to you quickly, didn't I?
Yeah, you did. I had a question, just for my own sanity to make sure that these definitions are like as simple as you read or, as they seem.
Mhm.
The variance that we've talked about today, that is simply just squaring the standard deviation.
Exactly. And really what you're doing is, when you're calculating it at this almost the last step, you have the variance and you take the square root to get the standard deviation. So yeah, I mean, you never really use the variance very much. The first thing you do with the variance is take the square root of it, so you have a standard deviation, basically.
Okay, and then same for like the z-score. It's literally just a values standard deviation.
So the z-score, yeah, just telling you where you're falling in reference to everybody else, how many standard deviations above or below the mean you are. So it can be positive, negative, or zero actually.
Yeah,
So
like you were
know,
saying,
like,
year zero. If you
right.
We're doing 70 inches for height. Can that
Right.
change in regards to like if like I'm taller, I'm 78 inches, so
Okay. Yeah, so you would be
because the
almost 3 standard deviations above the mean.
right. Would I just since the next one, if we're going, the standard deviation's 5, right? So like the second standard deviation would be 80. Would I put the answer for that just be 1 since I've fallen, or no, it would be 2?
Well,
It
I
just
think the standard deviation was 3, but it's whatever. It could be 2.2, it could be 2.4, it could be 2.786. Whatever
okay.
it
So
comes out to be.
we're not rounding for that. You're just
No,
using
no.
the desk. Okay, got it.
Yeah, it just that those ones I gave just happen to be whole numbers, but they can be anything.
Okay. Okay. All right. Yeah. I'll
And,
run down a few
Caleb,
questions
I
I
think that was
had.
Caleb I was talking to.
Yeah.
In chapter 6, we'll look into z-scores with great detail.
Okay. Yeah. I understand everything you've explained is fairly simple to get the answer to, but sometimes it's frustrating not understanding why we're getting to the answer or what the
Yeah, no,
exact
it's
importance of it is.
yeah, no, and that's I can't. Yeah, you can't teach the whole course in one night. So
Oh,
all
no, I
this stuff
understand.
is
Right.
just building.
Yeah,
Like
of course.
we're getting little concepts here and there, and as we learn more tools,
Yeah.
we're gonna get more meaning into it.
Yeah.
So-
Understanding how to do it, I just wanted to make sure I was understanding what exactly it is. Like I said, the
Yeah.
variance and all that good stuff.
Yeah, no, it start when you start doing 6, 7, 8. That's when it all starts coming together, and I'll explain it in great detail. Okay.
I think there's one other question I had saved from chapter 1. I don't know how important these are going forward, so whenever like I do have a question on something, even if we don't see it again, I just want to make sure I gotta find it real
Sure.
quick. That example you were giving us earlier, you don't get graded off of a natural grading scale.
No.
So it's literally just based off of whoever does the worst and the best.
Yeah, I mean, realize that you're competing against, really, like you can't get into a master's degree program if you're not pretty good in that field already. So the people are already, you already have a pretty elite crew already. Yeah, I mean, it just comes down to A or B, and if you do really poorly, a C. It's pretty much how it works. Yeah.
I was not under the impression of that.
Yeah, because sometimes if you went by just the actual grades and the test, I mean, some tests nobody can pass.
Right.
I mean, it's just they're just too hard.
Yeah, I got a lot of math ahead of me. I think I'm gonna do software engineering, so
Oh yeah,
yeah, it should be a blast.
yeah. You're just getting started, buddy.
I know. So I'm trying to do as well
It'll
as
be fun,
possible now. So
Yeah, it'll be fun.
I'm sorry. I thought I wrote down which one it was on the homework.
Sorry, guys. I'm just being nosy because Caleb asked good questions, so I'm just hanging in to see what other information I can get.
No problem. I totally understand what you're doing. I would do the same.
Thanks, Caleb.
I try. The military pays for me to go to school, so if I don't get perfect grades, I pay for it out of pocket. So I'm pretty content on doing as well as I can.
Ouch. I hear you. My employer pays for mine, so.
Yeah,
Nice.
exactly. Oh, I am terribly sorry. I wrote this down. It was about the frequencies. I wrote it down and I actually was gonna send an email to you, but then I just reread some of the chapter 2 with the frequencies and I had figured it out. So I
Perfect.
think I'm
Okay.
all good. So
So no help for Kayla. All right, perfect.
Right? That was
I know, it's
so
like,
unfulfilling.
sometimes I don't get the kids that sit in class or whoever may be that don't ask anything. And I'm like, you guys just get it just like that? Like
No,
I've
no.
heard some of these terms since high school.
Yeah, some
No,
of
no.
them get it, some of them don't.
Listen, math is not my strong suit. I'm pretty sure my algebra professor gave me a pity pass. So, I mean, I'm just chilling, hanging out, trying to get all the information I can get, but I don't really ask questions that great because half the time I'm still lost in translation. So,
Yeah,
when
I
I-
do.
when I
Well,
do
Kayla,
sit down
if
and
you're
do it,
having
it'll
trouble
take
in,
me
in
hours.
class, asking questions, don't just realize that you can always, when you're doing the homework, whatever, use that ask my instructor thing, and I can, work you with it, work on you with you when you need it. So, um, don't worry about, if you're not getting it all in class, when you have a question, ask.
Okay, awesome. I'm a little behind on my stuff, but I'm catching up this week. I had some family stuff going on, so
I
wasn't
understand.
able to get to it.
Yeah, I just
Right.
write down all the questions that I think are not worth interrupting for this right here. Just ask you at the end.
Okay, that's fine.
Yeah, everything seems to going for. I already read through chapter 4, so the whole time you were saying how hard it would be, I was like, yeah, it already looks hard.
Yeah, yeah, it can be. I mean, I'll try to simplify as much as possible, but there'll be some questions in there that will really aggravate you. Not all students hate it, but it's a higher percentage.
Yeah, but the way that you have it laid out, everything just waterfalls into the quizzes, which made the quizzes 10 times easier. Yeah, I think I
Good.
got like a
I'm glad to hear that.
99.8.
That's-
I inputted one wrong number on the frequency table,
Okay, good.
and that was it. So
Well,
it waterfalls really
that's my
well.
intention. I don't want there to be surprises. I just want you to know the material.
Yeah, I thought it was going to be overwhelming, but it is. If, like you said, if you go to pace, I mean, I think I just took 2 days out of the week after the first class to sit down and do it all, and it really was not bad at all. So
Yeah, and I think you'll find this week it will not be even as bad as last, and then next week it's going to suck a little bit.
yeah, cool. And to make sure, oh wait, no, you have it in the chat. Yeah, the TI 30, because I don't even have a calculator, so I'm just gonna get this one.
Yeah, anything that just get any cheap one. This is the only chapter we're going to use it for. So
Yeah, see, this one's only like $10 at Walmart. So
yeah,
Got
I think so.
alrighty, Professor, I appreciate you answering my questions as always. Thank you for the
Nope.
help.
No
Yeah,
worries.
thank
You guys,
Sure,
you guys,
and thanks,
guys have a-
Caleb.
yeah, you guys have a great evening.
Yeah, thanks you as
Yeah.
well.
All right, bye bye.